Imagine a world covered by a vast ocean, a planet on whose horizon there is no shore to wash up on. On the surface, absolutely no continent, no mountain range, no rock, nothing sticks out. Surprisingly, so-called ocean planets aren't just found in the imaginations of science fiction writers. It's believed that there are hundreds of millions of them in our galaxy alone. As you may have guessed, today we're going to explore the fascinating world of planets entirely covered by a single, very deep ocean. Because these submerged worlds are not only completely covered in water, but they're also made up of absolutely mind-boggling amounts of it, amounts that are hard to even imagine. So, if you found yourself on a hypothetical raft floating on the surface of one of these planets with no solid ground, you would be facing a landscape with no features other than waves, with water stretching as far as the eye can see in every direction for thousands of kilometers around you, and maybe even below you as well. Many believe these celestial bodies have oceans hundreds or thousands of kilometers deep, separating the solid core from the surface. Columns of water so thick that, in the dark depths of their extreme depths, they actually change the nature of the water itself. And this happens through a phenomenon so astonishing that it might make you see your glass of water differently forever. As a starting point for this exploration of the extremely varied forms that ocean planets can take, let's begin by considering the scale of the deluge on a world we know well, our own. Seen from space, on the Pacific side, Earth truly lives up to its name as the blue planet. But this color is actually misleading. Because even though this world is the only one in the solar system to have liquid water on its surface, in terms of volume, blue gold makes up only a very small portion of its mass. So, even though the oceans cover more than 70% of our planet's surface, if we gathered them all in one place, they would all fit into a bubble of barely 1,400 kilometers in diameter, which is the distance from London to Rome. In fact, our planet isn't as wet as it seems. All the oceans make up only 0.023% of its total mass. The rest is just minerals, rock and metal, from the crust to the core. And that tiny 0.023% is enough to cover 2/3 of our planet's surface, with a layer of water that's on average 3.7 kilometers thick. Just imagine, if the Earth were made up of just 1% water by mass, it would be completely covered by a global ocean, with even the top of Mount Everest underwater. If you increase the amount of water to 15% of its mass, the Earth would have oceans nearly 100 kilometers deep. That's almost 30 times deeper than Earth's average ocean depth. And it's hard to imagine what extremely wet planets might actually look like, some of which are thought to be made up of more than half just water. So I'll try to roughly summarize, without drowning you in calculations, what our observations and simulations tell us about the wild peculiarities of these water worlds. Each one crazier than the last. First, let's remember that the picture I painted for you in the introduction only applies to the specific case of an ocean planet where the surface water is in a liquid state. But a planet with the same composition and mass could, based on its history, distance from its star, and the star's traits, have turned into a real hell and have a thick, burning atmosphere, or be completely frozen on the surface and covered with a thick layer of ice, turning into a total ice planet. That being said, let's now dive into the extraordinary range of possibilities offered by these water worlds. Today, we believe that most total ocean planets are, in their characteristics, extremely different from anything we find in our solar system. With radii and masses between 1 and 4 times those of our planet. They are generally located between Earth and Neptune, and depending on their size, they are called super-Earths or mini-Neptunes. These planets, just like all those in our solar system, must have a core, made up of heavy elements, which during their formation sank to the center to form a metallic core surrounded by rocks. And that's about where the comparison ends. It's believed these worlds likely became aquatic due to unique histories. Most of them formed on the outskirts of their solar system, beyond the frost line, in a way similar to the core of Saturn or Jupiter. But later, they failed to become gas giants and evolved differently, becoming mini-Neptunes or aquatic super-Earths on steroids that first formed far from their stars, before gradually moving closer to them over time. Let's begin by adding water under the gas as we examine the largest ocean worlds, the mini-Neptunes, which studies suggest could be water-filled, to the point that they could be made up to 50% of this single liquid, with consequences that become extremely bizarre. It is believed that some of these planets, due to their mass and their distance from their star, may have retained a thick atmospheric envelope around them, mainly made up of light gases, much like Neptune. Thus, some of these bodies may appear as gas giants, concealed beneath a very thick atmosphere of light gases. An extremely deep global ocean. The recently discovered exoplanet 4218b belongs to this category of mini-Neptunes. And it's very likely that this cloud-covered planet hides a single vast ocean beneath its veils. Another possibility that I personally find fascinating is the idea that the hottest of these mini-Neptunes, just like some super-Earths, can turn into so-called sauna planets. That is, worlds whose thick atmosphere has literally turned into a hot and humid hell. Indeed, in many scenarios, ocean planets can end up surrounded by an atmosphere so thick and heavy that the liquid water on their surface can reach considerable temperatures without actually boiling. Acting like the lid of a pressure cooker, the atmosphere pressurizes the underlying ocean, allowing the water to remain liquid even at temperatures well above 100 degrees Celsius. Consider that on ocean planets relatively close to their star, with a size 2 to 4 times that of our planet and a mass about 10 times greater. Then, with the runaway greenhouse effect, you can end up with an atmosphere so dense you could cut it with a knife and mostly made up of water vapor. At nearly 200 degrees, with an ocean underneath. Just for the thrill of danger and risk. Picture yourself in an atmosphere thick with water vapor, where the sky endlessly swirls and unleashes boiling rain. Tossed on the waves of a global ocean, heated to the brink of boiling and kept in a liquid state only by the overwhelming pressure exerted by the thickness of the clouds. That's an end-of-the-world scene you couldn't see anyway. Such worlds would have extremely thick atmospheres. We are talking thousands of kilometers, so everything on the surface would be in constant darkness. No ray of sunlight can reach down here. It's also believed that on these sauna-like worlds, the violence of weather phenomena isn't limited to just the surface, because there's no solid ground to deflect or stop them. The dynamics of the underlying ocean currents must far exceed anything we know on our planet. And even if we can't know exactly how the currents behave on the surface there. However, we do know for sure that diving into these aquatic worlds, whether they are frozen on the surface, liquid, or like a sauna, will make you see the nature of water differently. Because in daily life, we only know it as solid, liquid, or gas. Under these worlds, water takes on an exotic form after just a few dozen kilometers of depth. As pressure increases, it shifts from a liquid to a supercritical state. It then adopts a superfluid behavior, acting both like a liquid and a gas, and no longer has a well-defined chemical surface. And if you don't find that strange, then you're not sane. And where it gets even crazier is when the planet is several hundred times richer in water than ours. By going even deeper, you would inevitably have to stop before reaching the bottom. That applies regardless of these worlds' surface temperatures. In a way, these deep extraterrestrial liquid oceans end up running into themselves, being stopped by their own immensity. Because, long before reaching the surface of the mantle or the rocky core, deep inside all these ocean planets, the liquid water turns into a form of exotic matter. Ice that moves and may also be hot. and whose existence is made possible by the hellish temperatures and pressures that prevail several hundred kilometers deep in these oceans. These strange ices, which are numbered according to the structure of their crystal lattice, have nothing to do with the ice of our glaciers or our icebergs. They have neither the same temperature nor the same structure. They can be hot, and they are also considerably denser than liquid water. So, they sink and collect deep within these planets instead of floating, to the point of completely covering their rocky core. We're talking about hundreds, even thousands of kilometers of hot ice thickness. So, in the case of a planet with 6 times the mass of Earth and made up of 1/3 water, you end up with oceans that are nearly 13,000 kilometers deep. Above all, only a small part is liquid, when the vast majority ends up as ice crushed, hotly compressed, and crystallized by its own weight. These arrangements of ultra-compact water crystals have even been observed and studied on Earth in laboratories, where they are created by compressing water to several tens of thousands of atmospheres of pressure. Type 7 ice has also been found in diamond inclusions, where it would have formed from liquid water, trapped inside the precious stone, subjected to very high pressures deep within our planet. To sum up, the depth at which the liquid ocean ends and gives way to these strange forms of exotic ice. It's not just the water amount on these planets. Mass, gravity, and surface temperature also play major roles. And since these can vary greatly, a whole range of ocean depths is possible. If you take, for example, a planet 6 times more massive than ours and made up of 50% water than the supercritical state, then high-pressure ices generally start to appear at about 100 kilometers deep and continue on and on for thousands of kilometers of dizzying thickness, all the way down to the rocky core. While a super-Earth 10 times more massive than ours is still made up of half water, will it only have columns of liquid water about 50 kilometers thick? Here, in any case, the thing to remember is that if you dive into a massive ocean planet, you inevitably end up hitting a frozen crust. Even if, on the other hand, for ocean planets less massive than Earth and with relatively low surface gravity, it is theoretically possible, if these are composed mostly of water, to be covered by columns that remain liquid. At 1,600 kilometers thick, 1,600 kilometers deep, this is currently the abyssal limit that can be reached without ice ever forming. If you struggle to picture this vast amount of water covering the rocky core of these hypothetical small planets, just think, that's 450 times the average depth of our Earth's oceans. To really grasp the incredible variety of forms these ocean worlds can take, let's examine an exoplanet with 8 Earth masses, 70% water, and a core like ours. Then, let's have some fun by changing its surface conditions in terms of pressure and temperature and see what happens. If the surface temperature is minus 50 degrees, the planet becomes covered by a 10-kilometer thick ice layer. Beneath that, without any transition, there are thousands of kilometers of pressurized hot ice all the way down to the planet's core. Maintain the same surface pressure, but increase the temperature to minus 5 degrees. And strangely, the thickness of the ice sheet increases slightly. Above all, it now allows space at depth for a liquid water ocean tens of kilometers deep. Trapped between 2 ice layers, regular above, high pressure, and warm below. Increase the surface temperature by 25 degrees and the ice sheet vanishes instantly, and you find yourself directly at the surface, with an ocean of liquid water several dozen kilometers thick, giving way at depth to still astonishing expanses of pressurized ice. Raise the temperature even further until it's over 175 degrees at the surface, and multiply the pressure by 10. And now the thickness of the liquid ocean has practically doubled, and it is followed at depth by water in a supercritical state. Bring the temperature back down to over 75 degrees Celsius, but this time lower the pressure significantly. And now you have a planet covered by a few kilometers of atmosphere, with water vapor beneath which a liquid ocean is hidden, which then transforms again after descending a few dozen kilometers deeper into hot ice. Raise the surface temperature further up to 220 degrees. Now the planet appears slightly swollen, its surface fully covered by a several hundred-kilometer thick water vapor-saturated atmosphere. Directly beneath this layer, and for nearly a third of its radius, it hides thousands of kilometers of water in a supercritical state, which then gives way once again to high-pressure ice. In short, to sum it up in a few words, it's a delightful mess of possibilities. These possibilities are even more exciting thanks to data from about 5,000 discovered exoplanets. Researchers believe that these ocean worlds could actually outnumber rocky planets. In the Milky Way, they could make up about a third of all planets. If that's the case, these water worlds likely exist by millions or even billions. So we have every reason to think that even if, for now, these possibilities remain mostly theoretical, statistically speaking, by sheer luck, each of the worlds we've talked about must have happened at least once. And it's amusing to think that the day we might be able to get direct images of them, these planets might literally show us all sorts of colors. It's believed they likely wouldn't look blue from space, contrary to what we might imagine, based on their history, star types, and orbital variations. The types of elements dissolved in their oceans, such as chemical peculiarities, their atmosphere, and its influence on the scattering of light. These planets could very well display a wide variety of shades, visually ranging from milky blue to white, as well as green, orange, or reddish appearances. And even though our telescopes are not yet able to give us a detailed view of them today. Among all the exoplanets that have been definitively identified, it is believed that we have already detected dozens of strong candidates for the title of ocean planets. Besides, without having to look so far, these worlds are almost certainly practically within our reach. Because in our solar system, the satellites of Jupiter, Europa, Ganymede, and Callisto, or of Saturn, such as Enceladus, almost certainly conceal them on their surface. More liquid water than our combined oceans. Many projects aim to someday pierce the frozen surfaces of these distant moons, in order to see if in the dark depths of these sunless realms, life has appeared. But I've already told you this story in a previous episode. The possible forms that exoplanets can take remain an inexhaustible subject that would require dozens of videos to cover properly. So at the end of this video and in the description below, I'm giving you a playlist to discover some of the strangest worlds we found, as well as the ingenious ways we use to detect them. Glasses of water share the ocean's passions. Thanks to Cité de l'Océan and Aquarium of Biarritz for supporting this episode, to offer us a bubble away from the world of Earthlings, a privileged access to underwater mysteries. If you're in southwest France, visiting them is a must to experience underwater immersion while staying dry. At the aquarium, you can closely observe many fascinating underwater inhabitants. Behind the glass of one of France's largest tanks, you can watch the graceful movements of around 10 shark species, like in other tanks, with jellyfish and their flowing umbrellas. At the Cité de l'Océan, you'll find plenty of fun, educational content about the ocean. With interactive experiences, 3D animations and simulators, you can hear, touch, and experience the ocean's big and small stories. And this, from the tropics to the poles, from the surface, from the waves to the great abyssal depths. Where sunlight never reaches on our planet, and on others where hot ice forms. All good things must end except sea cucumbers, which have two for support. Glug glug to them, and especially to you.